Hello students, welcome to today's lecture on PPSUC. In our previous session, we have discussed about introduction to pointers and how to allocate memory during runtime with the help of dynamic memory allocation. Today, we'll discuss about some advanced concepts related to pointers. Then we'll see how pointers can be used to point to 1D arrays, 2D arrays, and also how they can be used to represent the functions also. That means to refer to functions also, right? So to understand all these topics, you must have heard the previous videos from this unit. So if anybody is not watched the previous video, introduction to pointers, please watch that video first and then come back to this. Let us begin the concept of array of pointers. We know that an array is a collection of data types, similar data types. Now we have represented arrays of values only. Now we can create array of pointers also. We know that a pointer is capable of storing address of a general variable. Therefore, if you want, you can create an array of pointers that can store several addresses in continuous memory locations. Okay. That is, array of pointers can store several addresses in continuous memory locations. The syntax for creating array of pointers is data type star, pointer variable name, followed by the size. This size represents the number of pointers that we want to create. That is the number of addresses that we want to store in physically continuous memory locations. Okay. Let us see an example to understand it. Say I'm declaring a variable int star p of 5. This will create 5 pointers because the size is mentioned as 5. Therefore, p can store 5 addresses in physically continuous memory locations like this. Assume that x is an address of some variable, y is an address of some variable, z is address of another variable, w is address of another variable, u is address of another variable, and so on. So we can store addresses into these memory locations where p is holding the base address of the entire array. Okay. So like this, we can create an array of pointers where each location can be used to store address of some variable. So this is about how to declare an array of pointers and how to store values in it. The second concept is what is a pointer to an array. That means we can create a single pointer that can refer to an existing array. Okay. So once you declare a pointer to an array, either you can use name of the array or you can use this pointer to perform operations on that array. So how we can do this? Look at the syntax and data type followed by star pointer variable name. This should be kept inside brackets and then followed by size of the array to which you want to point this pointer variable. So you need to remember this. Parenthesis must be used to group this star and the pointer variable name, and followed by it you should mention the size of the array which you want to point through this pointer variable name. Okay, so these two are compulsory. You need to remember these two. Otherwise, there will be some mismatching errors in your program. Right. See this example to understand the theory part. I am declaring a pointer variable int star p. So p is a pointer variable that can point to an integer array of size 5 locations. So you need to remember this. This P now can point to an integer array of size 5 locations only. You cannot use P to point to other arrays. Okay. Therefore, I'm declaring an array, integer array, with exactly same number of locations, 5 locations, because P can point to only an array of size 5 only. Yep. And then I'm assigning P is equals to A. That means base address. A stores base address of the entire array. I am copying that base address of entire array into this pointer variable P. So P is equals to A. Now you can observe this. Both P and A are storing the base address of the entire array. Therefore, you can use either this name A to access the elements of this entire array, and then P also now can be used to access the elements of an array. Okay, so now there are two ways to access the elements of array. Either you can use direct name A, which allows direct access to this array, or you can use a pointer variable to access indirectly the elements of the array. Okay, so for once you assign base address from A to P, it means P and A can act as alias names for the same array. Okay. Uh, the next topic is how to represent the two-dimensional arrays with the help of pointers. We know how 1D arrays can be represented using pointers. We can declare a pointer and store the base address of the array into that pointer. Now, when it comes to two-dimensional array, you require a array of pointers. Okay, and then you can also use a double pointer also to represent a two-dimensional array and assign the base address of entire two-dimensional array into a double pointer, which can be declared as int star star p. Okay, so if we assign the address of first element to pointer p, which is declared as a double pointer or array of pointers, then we can access the elements of a matrix A by using the notation. All of you need to remember this notation: star of p plus I plus j. This is equal to accessing the array with the help of a notation p of ij. Write it, p of ij. Okay, so this is same as writing it as p of I. Both are same. So writing p of ij or writing star of p plus I plus j, both are going to be same. This is called as pointer notation, and this is array notation. Array notations can be replaced by the pointer notations also. Okay, so these are same. These two are same. Where I represents the row index and j represents the column index. Okay, and another thing you need to remember is when you represent it as a pointer, today array as a pointer, then p plus I means that based on I, if I is 0, p points to the first row of the two-dimensional array. If I is 1, that means p plus 1, p now points to the second row of the two-dimensional array. If I is 2, then p points to the third row of the two-dimensional array, and so on. Okay, so remember that notation. uh, when you increment I by 1, it automatically moves to the next row. If you increment j by 1, it moves to the next element in the corresponding row pointed by p. So always remember that I represents row and j represents column value. If we increment I by 1, it moves to the next row. If we increment j by 1, it moves to the next element in a particular row. Remember that notation. Okay. Yeah, it's this. Have a look at this example. I have created a two-dimensional array. A of 3, 3 is equals to the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is the arrangement of elements into the memory locations. 9 elements are stored continuously like this, and we can access them using the general indexes. 0, 0 means this element, 0, 1 means this element, 0, 2 means this element, 1, 0 represents this, 1, 1 represents this, 1, 2 represents this, 2, 0 represents this, 2, 1 represents this, and 2, 2 represents this. If you want to see how P of 2, 2 is evaluated by your computer, P of 2, 2 is actually calculated as star of P plus row index plus column index. Okay, because P of 2, 2, row index and column indexes are 2, it is equals to star of P plus 2 plus 2. For this value, star is given. Okay, so P represents the base address, P plus 2 represents the third row. Okay, so base address of the third row. Star of P plus 2 is now representing base address of the third row. Now for this, we are adding plus 2. That means it moves on to, because it is already here, it moves on to 2 more locations. Plus 2 we added, therefore moves to 2 elements in the third row. Star of P plus 2 is representing the first element of third row, and if you add plus 2 in jth index, it moves to 2 locations from here. Therefore, what is the element pointed? It is 9. So star of P plus 2 plus 2 is referring to this element 9. Okay, I repeat the explanation again. Star of P plus 2 is representing the first element of the uh, row index 2. Okay, that is pointed by index 2. That means it is here. Star of P plus 2 is here, the address of this location. Because we are adding plus 2, from here, 2 more locations it moves. Therefore, it comes over here, it representing the value at this location 9. Okay. Here are some notations, example notations to understand how it is actually represented. P representing the pointer to first row because it stores the base address of entire 2D array. P plus I pointer to I plus 1th row of the 2D array. Star of P plus I plus J represents to a pointer to jth element in ith row, whereas star of P plus I plus J returns the value stored in the cell I comma j. Okay, that's what we calculated. P of 2 2 is equal to star of P plus 2 plus 2 will return the element at index 2 2. The element at index 2 2 is 9. It returns that value. Okay, so you need to remember these notations to understand how 2D arrays can be represented formally with the help of pointers. Next concept is how pointers can be used as function arguments. This topic we will discuss in 5th unit because when pointers are used as function arguments to catch the addresses sent by function calls, which is called as call by reference. We'll discuss about these parameter passing mechanisms in 5th unit with respect to functions. But as of now, what you need to remember is you can send address of variables as parameters to functions. In function definition, we will make use of pointers as function arguments to catch these addresses forwarded by the function calls. Okay, as of now, just remember that point. And also, when you use pointers, then functions can return more than one value. So that is an advantage of using pointers as function arguments. Next thing is how pointers can be used with strings, working with strings. It is similar to character arrays or one-dimensional arrays. If you declare a character array like this to store strings, it is capable of now storing strings. We can declare a pointer, a char pointer, to store strings also. So this is another notation which can be used to store string values. Okay, either you declare like this or you declare like this name can be used to store strings. Okay, and if you declare a character pointer, you have an advantage. That is, you can use assignment operators to store strings directly into the corresponding character pointer. That is the advantage you will get. Whereas in character array, if you declare like this, you cannot store strings into this name by using assignment operator. You need to use strcpy function, string copy function, to copy any string into this character array. Okay, or else you can initialize, but when you want to define a value or assign a value to it afterwards after declaration, it's not possible with assignment operation. You need to use only strcpy function. But if you declare a pointer variable, it is possible to store the strings by using assignment operator itself. And when you assign a string into it, automatically a null pointer, that is a null character, is created by the system to represent the end of the string. Okay. The next thing is pointers can be used to point to functions also. Till now, what we know is pointers can be used to represent regular variables, that is general variables, and also we can use pointers to refer to 1D arrays, 2D arrays, character arrays, and so on. But this is uh, another advanced topic where pointers can be used to point to functions. An interesting topic. That means when you create functions, you can actually directly call them, which we will be learning in fifth unit. The topic is in fifth unit. And also, there is another way of calling the functions without using their names. That is possible with the help of pointers. So indirect calling can be done with the help of pointers. To declare a pointer variable to a function, you need to use the syntax. Specify the data type of the corresponding function. This should match the type of the function, the return type of the function, and then star followed by a name, a pointer variable name, followed by, this is important, you should give a set of empty parentheses to represent that this is a pointer which can point to a function. Okay, so data type followed by star pointer variable name followed by a set of empty parentheses, a pair of empty parentheses. Okay, so look at this example, int star p followed by empty parenthesis uh, uh, represents a pointer p that can point to a function which has integer return type. Okay, integer return type. Now look at this example to understand how pointers can be used. Assume that this is the pointer which I have declared int star p with a parenthesis. That means I can use this parameter p, that is pointer variable p, to point to a function which has a return type integer. Okay. Now you can add, you can use this pointer p to store the address of the corresponding function, assuming that add is the function name. Let me write the function also. Uh, Suppose I have a function like this, int add. Suppose it is taking two values, int a comma int b. Okay. Now I'm using int s is equal to a plus b. I'm just adding the values. Then I'm returning the value s from this function. So assume that this is the function I have, and I'm using the pointer p, which I declared in the previous slide. P is equal to ampersand add. Add is the function name, and I'm taking address of add. Okay, address of that. What you need to remember is function names also uh, stored into the memory location. Therefore, they also have addresses. So ampersand add returns the address of this function add. Add is the function name, and ampersand returns the address of this function. Okay, or you can directly use p is equals to add. Okay, the name itself contains the address, therefore you can directly use the function name also for storing the address of a function into a pointer p, right? So once the address is assigned to a pointer p, now actually if you want to call this function, the syntax will be like this: add of, suppose I want to send two values, add of 10 comma 20, you can call like this. And because it is returning the result, you can use some uh, variable r to store that result of add of 10 comma 20. Once this function returns the value by adding up, a gets 10, 20, b is getting 20, 10 plus 20 is stored in base, and we are returning that result 30 from this function, and that 30 will be now copied to r. So this is a direct calling of function. Now because pointer p is pointing to the same function, I can use now the pointer to call this function indirectly. That means you can call it as star p of a comma b. In place of a comma b, you can send 10 comma 20 also. If a stores 10, b stores 20, they will be forwarded to these parameters, and then the value will be returned. That is, the result will be returned. Okay, so since p is pointing to the function, either you can call the function with its own name, or you can use star p to call the function. So there are two ways now: either directly call it or indirectly call it. Okay, so this is about how we can use pointers to functions. Right. Now, the next topic is we can use pointers to point to structures also. So in uh, third unit, we learned about how to create structures and structure variables. Uh, Suppose assume that there is a structure definition, struct book, with three members in it: char title of 20, char author of 20, uh, and int number of pages. Actually, this is 20. 2 is not sufficient here. Okay. Then you can create a structure variable struct book b1, and then you can use b1 to refer to these members using b1 dot title, b1 dot author, b1 dot pages, and so on. We have already seen this example, and we wrote some programs also to implement this book structures. Okay. Now there is another way to refer to this structure, book structure. So let us assume that I have created a pointer which is of type struct book. Okay, struct book star p declares a pointer variable p which is capable of storing address of a structure variable. Let us say b1. Okay, so is now capable of storing address of this variable b1. Okay, assign it. Say p is equal to ampersand b1. Okay, now b1 address is stored into p. Now p is pointing to whatever is pointed by b1 variable. Okay, now either you can use b1 to access the members of the corresponding book structure, or you can use p to access the members of the same book structure variable b1. Okay, now instead of using b1 dot title, b1 dot author, b1 dot pages, you can use p arrow title, p arrow author, p arrow pages to refer to the same members of the structure variable b1. Okay, so remember this. There are now two ways to access members of a structure variable: either using dot operator, if you create a variable of the corresponding structure definition directly, or if you create a pointer, then use arrow operator to access the members. So there are two ways to access members of a structure: using dot operator or using arrow operator. This is also called as member selection operator. Okay, so this is about how pointers can be used to represent the structure variables, and how the pointers can be used to uh, access the members of a structure variable. Okay, so uh, that's all for today. That is what I want to discuss, all the advanced topics. We will see some example programs in our next session. We'll make use of these pointers and dynamic memory allocation. Uh, then we'll see some sample programs to understand how exactly these pointers works with the 1D arrays, 2D arrays, and structures. Okay, in our next class, we'll be discussing that. Okay, that's all for today. Thank you all for your patient listening. See you in next session.